One issue you can run into when we're pumping a single hand line off of an engine and we're hooked up to a positive water supply, meaning a fire hydrant, is you can run into the issue of your static pressure, meaning the pressure coming from the hydrant into the pump of the engine is drastically higher than your pump discharge pressure, meaning the pressure that you pump a single hand line at. A good example would be our 200-foot cross lay of 1 3/4 with our Elkhart fog nozzle at 150 GPM. The pump pressure on that is going to be 90 PSI. A lot of the blue top hydrants that you're going to find around here are going to give you drastically higher than 90 PSI, generally in the range of 100 to 120 static pressure. So how do you manage that difference, that 20 to 30 PSI difference from what you need versus what you're getting? Couple different solutions. One of them, we can actually gate down the intake, the ball valve intake on our engine and reduce the amount of pressure coming in. The issue you run into with that is later on in the operation, if you add more hand lines, increase your pressure, change your tactics, whatever it might be, you're going to need to utilize that excess pressure that's being gated down. So you're going to have to, as the driver, remember you gated it down, hop down, open the ball valve fully. Another option you have is going to be just gating down the individual discharge for that hand line that you're pumping. Problem you may have with that is when you have a higher static pressure than what your pump discharge pressure is, the pump boss, the electronic computer located inside of this that manages all of your pressures for you in the pressure mode, is not going to engage that pump when your set pressure is so far below what your intake pressure is. So you're going to be gating it down almost till that discharge is completely closed. It is an option, it just takes a lot of work and you really got to pay attention to it. A third option you have on there is going to be setting up a dump line. This is only going to be in situations where you're in a residential neighborhood, an industrial area, somewhere with hard compact road, not in your rural area, because you're going to set up a 3-inch line going off of one of your discharges on the side of your engine, and you can shed some of your excess incoming water off that dump line. Again, making sure you're not going into dirt, gravel, anything that can erode and compromise the structural integrity of the surface your engine is parked on. One last option you have to manage that extra intake pressure is going to be setting your pump discharge pressure higher than what your static pressure. So what I mean by that is if your static pressure is 110, let's say, set your pump discharge pressure to 115 or 120, a little bit higher than what your static pressure is. What that does is that engages the pump boss, gets that pump spinning through there, gets the computer system running on it, and then taking your actual discharge and instead of fully opening it, gate it down until it's at that, in this situation, 90 PSI you needed for that individual hand line. So the whole purpose of this evolution today was to show acting engineer McIntyre the difference in pump pressures from supplying an aerial through the waterway intake versus the actual aerial's pump. When you supply an aerial through the pump, what it allows you to do is split the workload between not only the supply engine, giving the water from the hydrant to the aerial, but the aerial itself. Our numbers on that one, we were running in RPM mode since essentially we were doing a relay pump. The aerial started out about 1,300 RPM, engine started out about 1,000 RPM. The two drivers of the apparatus communicated with each other to increase or decrease their pressures. Towards the end, we were able to achieve about 1,100 gallons per minute coming out of the waterway, with the truck pumping about 1,800 RPM and the engine pumping about 12 to 1,300 RPM. Now in contrast, when we hooked into the waterway intake for the aerial then essentially became a giant appliance. What it simulated was the pump on the aerial just completely died on us. So we had to divert our intake from the pump to the waterway intake. Driver engineer McIntyre had to go through his pump calculations to determine he needed approximately, we started out about 160 PSI. With 107-foot elevation, you had your 80 PSI nozzle pressure for your smoothbore master stream, and then you had about 100 feet of 5-inch on the ground. When we started flowing about 160 PSI, on our flow meter was showing approximately 850 to 900 GPM. We steadily increased our PSI pump pressure on the engine in about 10 to 15 PSI increments. We ended up about 220 to 230 PSI just to achieve that same amount of GPM flow out of the aerial at 1100. So as you can see, that engine, when we go through the waterway intake and treat that aerial as just a giant appliance, that engine was screaming. The pump was completely maxed out to achieve the same amount of GPM as if we supplied that aerial through their pump, use the RPM relay pumping modes, and we're able to split the workload between the two. So as you can see, that what this demonstrated is it is drastically more efficient for you to supply an aerial through the pump than it is to go in through the waterway intake.